Hello everyone, so this video is the simulation of the previous video. So just you should watch the previous video and come back here, otherwise it is not going to make any sense to you. Okay, so I'm considering you have watched the previous video and you have and you have come to this video to see the full demonstration. Okay, so I have pasted the code perfect. Okay, and I've started the simulation. Okay, so you see after a dot 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 line we have zeros and zeros. Okay, so what does it mean? That means once one iteration is finished, okay, we will have a dot dot line. Okay, then after the dot dot line, next iteration will start. Again these lines will be printed. Okay, so I will know after one dot dot line, first x will be printed and then y will be printed. Okay, so that's all I wanted to know. Okay, so x is what? This input value, y is the output value. That means the new mapped value we are going to give. So you know those things. Okay, so now it's 0 in both cases, because you know if the initial value x value is 0, okay, because this input is always 0. Okay, now x value is 0 in this range, again in this 255 range also it is 0. We know that, right? It's totally cool. So that's why we have both are 0. So I will try to increase and let's see what happens. So you see, while I am increasing, the values are changing. Okay, that's really good. Okay, so now you can see my x value is 184. That means my input value, analog grid input value is 184. Okay, you can see it. And the y value, okay, that means what? The mapped value is 45. Okay, so we can say 184 is the input value for in this range 0 to 1023. So if the value 184 from 0 to 1023, the respective value for that 184 in the 0 to 255 range, or in other words, in the range of 0 to 1023, the value 180 will be having the new value in the range of 0 to 255 is 45, or in other words, the value of 184 in the 0 to 1023 range, I'm sorry, how can I say, my English was wrong. Okay, we can say in the 0 to 1023 range we have a value called 184. The respective value for that 184 in the 0 to 255 range is 45. Okay, now I'm good. So you know what is happening. Okay, you can see still the LED is not on. Okay, let's see, we'll try to increase it. It looks like I was wrong, because while I was rotating the value is increasing. I didn't release my mouse. Okay, maybe I was wrong. Okay, so I apologize for that, guys. So I'll increase. So still you can see for 450 the respective mapped value is 112. Okay, so if the value is 450 in the range of 0 to 1023, in the range of 0 to 255, the respective value for the 450 will be 112. Okay, you understand what I'm telling? I'm repeating. If 450 value is available, I mean for the range of 0 to 1023, if the value is 450, the mapped value of the 450 in the range of 0 to 255 is 112. Okay, so for 1023, I mean for 0 to 1023, if it is 450, for 0 to 255 it is 112. Okay, that is a mapped respective value. Okay, if the input is 450, the respective output value will be 112. That's what I'm telling. Okay, so I will increase. Now the LED is on. That means now LED has got enough voltage to get the minimum brightness, at least. Okay, to start the brightness. Okay, because we know less than a particular voltage, the LED will not be even switched on. Okay, we need a minimum voltage. Okay, you cannot say I mean, if the LED is not switched on for 0 voltage, sometimes up to 2 voltage or 2.5 voltage, that LED will not switch on. We don't know. We should have the minimum voltage. That can be sometimes 2.5 voltage. Okay, so only when I am passing the respective analog value for that minimum voltage, the LED starts to switch on. Then actually, if I am increasing, the LED should be increasing the brightness. I don't know. It is not properly visible, so that's a problem, right? In the serial monitor, you can see the values are changing. Okay, so at least you can see that. Okay, this input value is now changing because I am rotating it, and also the respective output value also changing. Okay, see, I'm increasing, see, changing. Brightness is not properly visible, so we don't care. But remember, when you are doing it with your real Arduino, the brightness will perfectly increase. This will be amazing. Okay, this will amaze you guys. Okay, so let's bring to the maximum. Okay, so let's see the maximum is now 1023. The respective value is the maximum value of the next range 255. So this is perfect, right? Because if the x is 1023, the maximum value, okay, in this range, so x is 1023, that means there is a maximum value in this range. So what is the respective value for in this range? The maximum value of this range 255. That's what happening. See, input is 1025, 3, output is 255. Okay, so you can see here, if this is the x value, then here this will be the respective value, maximum value in the both range. Okay, that means if you are giving 1023 as an input, okay, then the output value should be 255. Respective output value will be 255, because this is the maximum value here. Here this is the maximum value. Okay, where here this is the maximum value. Here this is the maximum value. Here this will give 5 voltage. Here this will be here this will indicate 5 voltage. Here this will give 5 voltage. That's all. You know, right? So I'm not re-explaining it, guys, because I have been explaining continuously. So I will try to decrease also. So values are decreasing hopefully, and brightness is not visible, right? But at least you can see the serial monitor. Okay, for God's sake. Okay, so brightness is, you will see the brightness in the direct way. Okay, when you are using a real Arduino and LED and and this potentiometer and resistors, okay, you will see the brightness is changing perfect way. But still, if you are going down, now you can see the brightness is a little bit changing, right? No, I am not sure about that. Okay, don't see here only, like we can see a little bit. I am not sure. I don't know whether we are seeing it or not. Maybe we are seeing, we don't know. So you see, if you are going down a particular voltage, the LED is already off. We don't even have to go to 0, because even this voltage is not enough to switch on the LED. Okay, you should know this, right? Maybe for 1 voltage or 1.5 voltage, LED will not switch on. It needs a minimum voltage, or maybe 2.5, we don't know. Okay. Still, the voltage is increasing according to analog output, so we don't worry, because see, analog output is output and inputs are increasing, but the only thing is it is not enough to even switch on the LED. So when you are passing a particular value, yeah, it will switch on the LED. Then it will increase the brightness with the voltage. You understand how this works? Okay, so the best thing is, if you understand or not what I am saying, you can rewatch the video, and also you can do it by yourself. I encourage you also to have a serial monitor, okay, and watch the values changing. So while you are changing the values, also you are seeing the LED's brightness changing. Okay, so that will amaze you. Okay, you understand, guys? So if you want, you can write another logic. I mean, since you have the input and output values, you can write a logic small equation to calculate the voltage amount given here using this Y value, right? Using this analog value. For that, you have to do some calculation. So if you are smart enough, you can try it as a homework. And also with these values, you can print the output voltage as well. Then you will understand at which voltage the LED starts to switch on. And also you can see the analog value is increasing. That means analog input is increasing, analog output is increasing, and the output Y respective voltage value also increasing. Okay, the voltage value that goes to the LED. And then you will see with all the three are increasing, the brightness also increasing. You can see with your own eyes. Okay, you can write as a homework. If you don't understand, just don't worry. For the moment, if you understand, this input is changing, the respective correct analog output is changing, and the brightness is changing. If you could notice all the three things, and if you can explain the code line by line without a single mistake, then you are good to go forward, guys. Okay, so I hope you will do it with your real Arduino and the real environment, in the real components, and you will see this change in real, and you will enjoy it, I hope. Okay, so happy learning, guys, happy coding, and yes, stay safe and consider subscribing us. I will catch you up in the next video, guys. Again, stay safe, guys.